Hello and welcome to Sandbox, the Kinetic Sandtable that is both mesmerizing to watch and fun to interact with. Our purpose in designing this table was to build on existing Sandtable designs and add an element of play and interactivity, making it the perfect soothing entertainment for all ages and a tool for refining motor skills through physical therapy.
We started by fabricating the frame of the sandbox, choosing a petite square design about 20 inches in width and depth. From there, we 3D printed fixtures, supports, and mounts through Jacob's Makerspace at UC Berkeley. To assemble parts into a table, we made use of Core Student Workspace and Supernode at UC Berkeley. Here is our nearly finished table. The next step of manufacturing the table involved testing the motion along the linear rails. We chose to employ a gantry solution to be able to build on top of Gerbil software from 3D printers and CNC machines.
The next step was wiring electrical components. We added LEDs to create sharp definition for patterns drawn in the sand. We also added contact switches that activate when the motor mount reaches the 0-0 position, allowing us to rehome the magnet mount each time the mechanism starts up.
Up until this point, the Gerbil software allowed us to send coordinates one by one to the motors. By wiring up the Jetson Nano, we could send a stream of G-code coordinates to the Arduino for smoother motion. It was important to wait for feedback from the Arduino such that the timing between sending coordinates was sufficient. From there, we developed a user interface using Node.js and React. The interface features a draw, reset, and undo button, and also includes some pre-made patterns. Once the user sends a drawing, the ball moves to the starting position and completes the pattern through a live connection to the Python server.
We wanted to take the interactive component one step further by making the robot interact with the user live. We employed Google's finger tracking package, MediaPipe, to track the user's fingertip in the RGB video frame produced by an Intel RealSense camera. Based upon where the finger is in the RGB frame, the depth information from the RealSense is combined to get a 3D point in the camera frame coordinates that represents the fingertip. This point is then transformed into the table frame using an Naruko marker and a static transformation, resulting in a command that moves the ball to the position of the fingertip.
We are super proud of our version of the Kinetic Sandtable, building on an existing beautiful design to add an element of interactivity and playfulness. We hope you enjoyed watching, and thank you.